So now that we have those initialized, we got to tell the program which key we press in order for the projectile to be launched. So oftentimes a good projectile is one that's close to the running keys. So let's go ahead and say when we press the button E, then we're going to launch a projectile. Okay. So we're going to say in Projectile Tracker. I'm just going to put like some quotes here, and I'm going to write some numbers in here, and I'll explain this in a second. 001 is equal to int movement, int Projectile Tracker at 0, 1, 0 is equal to the, let's say, x position, and in Projectile Tracker 1, 0, 1 is equal to the y position. Okay, whoops, 1, 0, 0 is equal to the y position. And I'm going to also put a little, or those same values commented to the side. Okay. So every time we fire a bullet, we no longer want to have any control over it. And if we want to have no control over it whatsoever, we need this tracker to like keep track of everything, like I've kind of explained up there. Now, every time we fire a bullet, we need to be like armed and ready for the next bullet. So the first bullet we fire has to be at 0, 0, 1, because that's the first bullet, and this has to be 0, 1, 0, and this has to be 1, 0, 0. But the next time we fire another bullet, we need this to be like 1, 1, 2. We need this to be 1, 2, 1, and we need this to be 2, 1, 1. And then if we click the fire bullet button again, we need this to become 2, 2, 3, this to become 2, 3, 2, and this to become 3, 2, 2. Because we need every time we launch a bullet, them to be like completely unique in the way they're being fired. And typically, this is actually matrix algebra, which you actually learn in your, I believe it's your 3rd year of engineering. If you do become engineers, or if you attempt, don't be afraid. It's actually really easy at the end of the day. But we just need a way to make sure these numbers are cycling correctly so that every time we fire a bullet, the new coordinates are recording and tracking where that bullet is going. So luckily we have int clip created up here, int clip 1. So let's just, since int clip 1 starts at, where does it go? Where'd it go? Since int clip 1 starts at 0, let's just replace the zeros with int clip, and then the 1 with int clip plus 1. So it's going to, whoop, I wrote clop. Oops, and I wrote int clip 1. So it's just going to add 1 to the int clip location, so it's going to be from 0, it's going to go to 1, and it's going to look for the value there. And I'm just going to quickly do the same thing with these. The one's kind of redundant, but it's there. Okay, so now this location for every bullet will control its unique points. It's a little confusing at first, I admit. And now every time we fire that button or every time we press the E, we need to be sure after we've stored in all these values into their associated matrix, we need to make sure we add one to the clip. Or else it's going to try to like reuse this ammo clip, and we don't want it to reuse it, or else the values will start getting all jumbled. So now let's go write the private sub that's going to move the bullet. It's important to remember that the bottom coordinate is for int movement, the center one is for the X position, and the first one is for the Y position before we go into this. So let me scroll down to some free space, and we already have quite a bit in our program. Private sub. Let's call this Projectile Launcher. And we need to keep track of 50 bullets, since that's how many we fire. So I'm going to create a counter. And let's say it's equal to, let's give it a value of 1 right now. And then since we need to keep track of 50 bullets, let's say while int counter is less than 50, we're going to be doing some things. First off, we're going to be checking which movement is stored in the matrix. So if you remember from where we type in our keys, and I know there's a lot of code, if we type in W, int movement becomes 1. If we type in S, int movement becomes 2, so on and so forth. And over here, for that matrix, for that three-dimensional matrix, we are taking that 0, 0, 1 coordinate and we're storing in int movement into that location, 0, 0, 1. So we need to create an if statement that can replicate that. So if int projectile tracker is, so if int counter starting at 1 and we're trying to get this number over here, then 0 would have to be int counter minus 1. This is the same thing, int counter minus 1, and then this would just be int counter. So that's the location of int movement. And let's say if it's equal to 1. So if int movement is equal to 1, that means we press the up key. That means we press the up key. And if we press the up key, then we want to change the Y coordinate. So we want to change like the 1, 0, 0 like units. And when we run our program, the higher we get to the top, the higher we move up to this top over here, the smaller our Y gets, or like in pixels, because it starts at 0 pixels and then counts downward, 1, 2, 3, 4, 5, 6, 7, 8, like that. So we want to change our Y pixels for this. And let me get rid of that T. So if we press the 1 key, then we're going to want to change our int projectile tracker value of, and we said of the Y coordinate. So the Y coordinate, one more time. Even I forget, Y position's 1, 0, 0. So 1, 0, 0. And then we're going to change this to int counter, because int counter is the same thing as 1. We're going to change this to int counter minus 1, because that would be equal to 0. And we're going to change this to int counter minus 1. And since we're going up, or since the projectile is going up, let's minus from it. Let's start with 2 pixels at first. Okay. Next, let's do the down command. So I'm just going to quickly copy this since it's a lot of code. Else if. Okay, and if this is 2, because we're going down, this is up. I could even write it here. This is up. This would be down. Then we want to, if we're going down, we're actually adding pixels to the y coordinate. I believe our next one was left. And if we're moving this way, left, we're actually subtracting pixels. So we could subtract, but we're subtracting them from the x position, not the y position this time. And the x position is 0, 1, 0. So over here, we want 0. So in counter right now is 1. It's not 0, so we need to subtract 1 from in counter. Then 1, so we need to remove this negative 1. And then 0 again, so we can leave that over there. And then let me just copy this and paste it down here. And if int movement is equal to 4, which is right, then we want to add 2 pixels to that. Okay. So it's a little tricky at first, but take a look and try to see if you can kind of understand what's going on here. We're just keeping track of our coordinates of all the different projectiles based on how they're moving. And since we have 50 projectiles, we need to constantly keep track and add. Ooh, and add. Almost forgot that one. Every time we do this, we need to add 1 to the in counter, or else it'll be stuck in an infinite loop. So once it does this once, it's going to rotate again, and now it has the new values, but it all still works out. Okay, so let's go ahead, put something in our main program. We'll say we'll do this after we draw our character. Let's say draw our projectile. And our sub is called Projectile Launcher. And I forgot how to spell. Okay, and now let's finally go ahead and use int tracker. Int tracker. Right now it's set equal to 0. I think it actually might be better if we started at 1. And it actually doesn't really matter, but let's just set it to 1. Int tracker 1. And then we also need to check for all our bullets on the screen. So while int tracker is less than 50, yeah, 1 works better because if it was 0, it'd have to be going to 49. While int tracker is less than 50, let's go ahead and, since I have some white on my screen from my projectile, let me show you the white around it, and I want to eliminate that. Let's just do a BMP projectile dot make transparent. And let's just do color dot white. And now after we made that transparent, let's go ahead and draw the projectile. So draw image, and the image we're drawing is our bitmap projectile that we converted earlier in the program. BMP projectile. We converted it up here, by the way, BMP projectile. And then we need to specify its coordinates. So its coordinates in the x direction are int projectile, and then, or int projectile tracker, and then since it's x, that's why it's really useful to have this chart here. It has to be 0, 1, 0. So if int tracker is 1 and we need 0, 1, 0, then this is int tracker minus 1. This is int tracker, and this is int tracker minus 1. Okay, that was just our coordinate in the x direction. Now we need to do it for our y direction, so I'm just going to copy this, paste that down, and y direction's 1, 0, 0. So I'm going to remove this minus 1. I'm going to add minus 1 to here, and I'm going to leave that as it is. So that's 1, 0, 0. After we do that, we need the size of the pixel. So mine was 32 horizontal, so 32 pixels for my Pikachu from like this coordinate to there in X, and then it was 28 in the Y. So 32 by 28. So there. And last but not least, we need to add 1 to the int tracker. So int tracker plus equals 1. So that it will loop through all 50 bullets if you do shoot 50 bullets. So let's go ahead, give this a run. You see my character on the screen running around, and when I press the E key, I launch Pikachus. So it works pretty well. And it's able to keep it. And if I keep shooting Pikachus at it set at 50, it will eventually crash the program. So if I wanted to, I could change the number to 100 and have like 100 Pikachu shoot out. Or I could reset it at some point if I wanted to. Now Pikachu was going a little bit slow, so I could scroll back down here to where I launched a projectile. And when I'm changing the pixel amounts of the X and Y coordinates, I can increase this to, let's say, 10 pixels. So now Pikachu is displacing 10 pixels every time one of these loops runs. That's all in our int projectile launcher. So if you run it now and you press the E key, you should be firing Pikachus at a much more rapid speed than before. Okay, so that's projectiles. I know they are a little tricky to understand, but just take a look at the code. There is no activity at the end of this video. Just be sure you kind of understand what is going on before you move on to the next one.